Hello and welcome back to That Math Guy. Just wanted to cover a subject today. Should be a quick review, but place value. It's something that even teaching high school math, I saw students struggle with. As always, you've got my channel, you've got my email address if you want to make suggestions or ask questions. But instead of diving just kind of right into it, I sort of like to take the roundabout way, just because it's kind of fun to see why number systems work the way they do, whether it's ours, whether it's, maybe a system that we're not as familiar with. But I'm going to start with binary system. A lot of you guys know binaries, just zeros and ones. It's computer programming language. That's the number system they use. Essentially, you have two digits. You have 0 and you have 1, which is why it's called binary. Bi means two. And essentially, the 0 and the 1, they act like an on and off switch. There either is or there is not this particular place value. And so the reason that there's only two digits is because the binary system works on powers of 2. In other words, the first place value, the first digit, or the first place in the binary system is 2 raised to the 0 power, which is the ones place. It's the ones place. In other words, 2 to the 0. I'll put it like this. The second digit is how many 2's there are in that number. In other words, 2 to the first power. And on like that. As the number gets larger and larger, it's going to be the 2 squared place, 2 to the third place. So this is the 4's place, the 8's place. But you can see how this is going, right? We're going based on powers of 2. So 16, 32, on and on and on. So this is why binary works the way it is. It's powers of 2, and that's why there's only 2 digits in the system. So for example, let's see how this works. I'm just going to go ahead. Obviously, if we have this many spaces, we're not going to have a 0 out front. Similarly to what we do in our number system, we don't generally just put a 0 out front of all the numbers because it's pointless. So we'll put a 1, say 0, 0, 1, 1. Essentially, these numbers act like an on and off switch. So anytime there's a 1, there is that place value, there is that digit. And if there's a 0, there's not that value. So essentially, all we're going to do is add up. There's 116 here, 0 8s, 0 4s, 1 2, and 1 1. So all the ones that have the 1s on them are going to be added up. So 16 plus 2 plus 1 gives us a total of 19. If you were to translate that into our decimal system. So again, binary is based on 2 digits, and each space is a power of 2. That's exactly how our system works. We're just so used to, going with digits 0 to 9 that we just kind of take it for granted. But that's pretty much the exact same way that we work. Okay, our system is called the decimal system for a reason, because there are 10 digits. It's that prefix right there, decimal. Okay, deci means 10. And we use digits 0 through 9. Think about this. If you're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, what comes next? 10, which is 2 digits long. Meaning that we ran out of space in the single digit, and we had to start over, throw down a 0, and jump into the next space over. So that's why we have the tens place, etc., etc., etc. Once we run out of double digit, we go to the third digit, which is the hundreds place. So let's take a look at this again. Okay, like we were just saying, one space, one digit in our system means we're still in the ones place. Okay, but think about this. We're basing this on tens because there are 10 digits. So this is 10 to the 0 power, just like we started over here with binary with 2 to the 0 power, which is again equal to 1. It's the ones place. If we move over, we're now in the tens place. Well, guess what? That's just 10 to the first power. Hundreds place is 10 to the second power. The thousands place, 10 to the third power, and so on and so forth. Okay, obviously this is going to continue on and on and on that direction. The difference between binary and our system is that we can also show portions or pieces of one whole. Okay, so this is kind of as far as we go with the whole numbers. So how do we show portions? Well, we show that point, that decimal point. So that's kind of the separator between wholes and parts of a whole. Kind of cool. So here's the thing. If every time we move, we're going by a power of 10, means the factor is 10. We're multiplying by 10 as we move to the left. So as we move to the right, what are we doing? 1,000 down to the hundreds place, down to the tens place, down to the ones place. We're dividing by 10. So what we're doing is, instead of using 1, this is the 1 over tens place. So tenths place, or the negative first power. We'll get into powers exactly, and all that kind of stuff a little bit later. Next is the 1 100ths place. Okay, if you divide by 10 again, that's 1 100th. 10 to the negative 2. Next place over is the thousandths place. Again, this can continue as far as we go, but again, we're just going by factors of 10. That's all that it is. So for example, let's take a look. If we wanted to say $943.29, okay, you kind of take a look at this and say, all right, so this is 940, which is 4 tens, 943, and 3 ones. Okay, the 0.29 ends in the second decimal place. It ends in the hundredths place. So that's the same thing as saying 29 hundredths. There's 29 hundredths left over. Notice how the number of decimal places after the decimal is the same number of zeros as that place. So it's a little bit easier to remember that way. So the tenths place only has 1 0. It has 1 digit past the decimal point, and on and on and on. Just for the same reason you don't start a binary with a 0, you don't need to start, a number in our system with zeros, okay? Unless after the decimal point, you have some zeros and then a number. You have to enclose those, use those missing spaces. You have to use some zeros there. So for example, if I wanted to say 17 and 9 1,000ths, that's not the same thing as just saying 17.9. I have to make sure I've assigned everything to the correct place value. The thousandths place is not the first decimal place. Okay? If you look up here, it's the third decimal place. So we have to go to 3 decimal places, and our 9 should end there. So any missing spaces, you fill with a 0. Okay? So just a quick review. If you'd like me to go a little bit more in depth, I definitely can. But again, just using this as a review is a little bit of a refresher. As always, feel free to shoot me an email. Hopefully that helped.